in this class we will go through another very important property of transition elements, which is the ability of transition elements to form complex compounds. Right? Complex compounds, for example, what kind of complex compounds? Example, CrNH3 whole 6 plus 3. This is a complex compound. NiCO whole 4 is a complex compound. Right? Then there is another complex compound, which is your CONH3 whole 6 plus 3. All these are complex compounds, right? And cobalt, nickel, chromium, all these are transition elements, right? So transition elements show a very high tendency, transition metal ions show very high tendency to get attached to some neutral molecules or ions, right? Some neutral molecules like water, ammonia, and ions like chloride and fluoride, right? So these transition metal ions have greater tendency to form complex ions, right, with certain molecules or ions. So let's write it over here. Transition metal ions, right, have great tendency to form complex ions with certain neutral molecules, like cobalt, carbonyl, like carbon monoxide, and ammonia. It form carbonyl compounds, right? Transition elements with CO will form carbonyl compounds, and water, or with ions like fluoride and chloride, right? So what happens is, if this is your transition metal, right, these neutral molecules that possesses lone pair of electrons, right, or these ions, what they will do when these will approach, we call these as ligands, right? These metal ion, these ions or these molecules, right, that have lone pair of electrons, they approach these transition metal ions, right? So we call these as ligands, right? So when these ligands will approach this transition metal ion, what they will do is these ligands will transfer lone pair of electrons to this transition metal ions, right? So they will transfer lone pair of electrons to transition metal ions, right, forming complex ions with them, forming complex ions like these, right? So in these complexes, what's happening is, this neutral ammonia molecule, 6 ammonia molecules, will approach this Cr plus 3 ion, right, to form this complex, right? And these 6 ammonia molecules will transfer lone pair of electrons to the chromium ion, trivalent chromium ion, to form coordinate bonds with them, right? So these ligands, what they are doing is, they will form coordinate bond with transition metal ions. That is why the compounds that are obtained are known as coordination compounds. We will be doing these in detail in chapter coordination compounds, right? Now let's look at the metal. Why transition metal ions can easily form such compounds, or they can easily associate with these ligands, right, which are neutral molecules or ions. Since I said that these ligands will donate lone pair of electrons to these transition metal ions. So since transition metal ions, we know they have empty d orbitals, right? So since they have empty d orbitals, they can easily accept lone pair of electrons in d orbitals, right, in their empty d orbitals. Second is, we know that transition metal ions are small, right? Cations are small and they have high charge density. You can see Cr3 plus, this has high charge density and it is small. They are small and have high charge density. Right? That will help to form bond with ligands. Right? I hope this is clear till this point. Right? So these transition metal cations, like I said, these transition metal cations, they have small size and possesses high charge density. Right? Therefore, they can accept lone pair of electrons from these ligands. Right? So two important things. Why transition metal form complex ions? First is, they possess empty d orbitals, right? In these empty d orbitals, they can accommodate lone pair of electrons that are donated by these ligands, which are neutral molecules or ions, right? And the second thing is, these transition metal ions, they possess high charge density and they are small in size. They are small and high charge density, due to which they can again easily accept lone pair of electrons donated by these ligands. Right? I hope this is clear. So mainly this is an important question and have been asked in exams many times. You need to mention these 2 points. The question that would be asked is, why transition metal ions form complex ions, or why they show high tendency to form complex ions. It is because of available d orbitals into which they can accept lone pair of electrons, and due to their small size and high charge density, the lone pair of electrons are easily accepted. Right? I hope this is clear. Right? And we'll in the next chapter in coordination compounds, we'll see how exactly these complex ions are formed. Right? Because when in the formation of these complex compounds, hybridization of these transition metal ions take place. Right? We'll be doing this in detail in next chapter. Right? So for example, in this Cr plus 3, 6 ammonia molecules, right, which are 6 ligands, will approach and they will form CrNH3 6 plus 3. Right? So lone pair of electrons, we know that nitrogen has lone pair of electrons which would be donated. Lone pair of electrons donated will be accepted by Cr plus 3, right, to form this complex compound. Right? Why? Because of high charge density of chromium and its small size, right, and due to the availability of empty d orbitals. Right? Since it contains empty d orbitals into which these lone pair of electrons can be easily accepted. Right? So that is why transition metal ions show high tendency to form complex ions. Right? And one important thing to understand here is that if transition metal element have 2 oxidation states, right, then this stable complex will form in higher oxidation state. For example, if we talk about this cobalt exists in +2 and +3 oxidation state, but complex with CO +2 oxidation state is not stable, but complex with CO +3 is stable. right? This is a complex with cobalt in +3 oxidation state, whereas the same complex with +2 oxidation state is not stable, right? So transition elements, if they exhibit more than one oxidation state, complex with higher oxidation state has greater stability. I just mention over here, complex with higher oxidation state has higher stability, right? I hope this is clear. And in each transition series, the stability of complexes increases with increasing atomic number, right? Stability of complexes, if you look at the series, right, in the period, the stability of complexes will increase with increasing atomic number. So the metal ion with high atomic number will be more stable, right? So we say that stability of complexes will increase with increasing atomic number of the element and decreasing size of the atoms, right? We have discussed that small atoms will form these complex compounds easily, right? So it increases with stability of complexes increases with increasing atomic number, with increasing atomic number and decreasing atomic size, right? With decreasing size of the atoms, right? I hope this is clear. So you need to remember that these ligands that are approaching these transition metal ion to form complex, they will donate electron pair to these metal ions to form coordinate bonds, right? And these metal ions, why they easily form these complex metal ions? Because they have empty d orbitals, and due to their small size and high charge density, they can easily accept the lone pair of electrons to form bonds, coordinate bonds with them, right? I hope this is clear. Thanks.